Okay, Computer Science 150. Finishing off our discussion of arrays here in CS150. This is Chapter 8 in the Lake textbook if you're following along by reading. Today we're going to talk about two-dimensional arrays. So far we've seen one-dimensional arrays, and these are like a list. So each element goes inside the next one inside the list. The 2D array works like a table. So if we declare a 2D array that is 3 by 6, there are going to be 3 rows and 6 columns in that table. And again, we start counting as 0 in terms of the numbering. So table 2, 3 is going to be 0, 1, 2 going down, and then 0, 1, 2, 3 going over. So that would look like the third row, fourth element, but it's actually table 2, 3. And basically, in terms of declaring them, you give the 2 dimensions inside the square brackets. And you can use an individual element of that array like any simple variable. So, for example, we could see out that particular value. Again, the first dimension is the number of rows. The second dimension is the number of columns. And the important thing to remember is that the indexing starts at 0. These can also be initialized when they're declared. Elements of each of the rows are enclosed in braces and separated by commas. And then you separate those rows by commas as well. And for number arrays, you can do unspecified elements getting set to 0. This would be an example of initializing a 4 by 3 array. We would have the 4 rows and the 3 columns. The first one would be 2, 3, 1, 15, 25, 13, 24, and 7, 11, 18, and 14. And then to process the entire array, what you would want to do is instead of using a single for loop, you would want to use a double for loop, and you would want to have those nested. So the first one will go through the rows, and then the interior one for each row, it will go through and do the columns in that row. And so this would be a way of outputting the table. We could use a similar process if we wanted to get all the input for a table. Now, if you want to pass these as a function parameter, remember that when we did the one-dimensional array, we passed the array as the first parameter and then passed the size separately. For two-dimensional arrays, it's going to be a slightly different technique, and this was a design decision in C++. The function declaration for printing one would be void print const. So again, the const is there to not modify it. It's a type of array that is an integer type, and we give it the name A. We leave the first one blank, and then in the second one, we actually give the size, and then we pass the row size as a separate parameter. So why is that? Well, you know, to quote Led Zeppelin, they talk of days for which they sit and wait, all will be revealed. And that'll probably be revealed in CS450 as to why that design decision was made. For right now, the 2D array is actually an array of arrays. So it's a 3-element array of 6-element arrays. So what we're doing is we're past the one-dimensional arrays. The 6 is the like the data type of the array elements. So again, it's not something you have to worry about. This is just how it's done. And the function definition for printing this was pretty much what we discussed on the last slide. And then the invocation, we would pass the name of the array along with the row size. You're not limited to just one two-dimensional arrays. You can do n-dimensional arrays, and basically these are collections of fixed number of elements arranged in n dimensions, and you would just keep adding the ones enclosed in the square brackets as long as you wanted to keep making the dimension larger and larger. And the same thing to access the component. So in summary, in looking at arrays, an array is a structured data type with a fixed number of components that are all of the same type. We access them using their relative positions within the array. The elements of one-dimensional array are in the form of a list, and we can use an array index that's an expression to evaluate in order to access those elements. But the caveat is it always needs to be less than the size of the array. The base address of the array is the address of the first component, and then when passing it as an actual parameter, we only use its name. We pass by reference and then indicate the size. A function cannot return an array type, again, because we're passing by reference. We're modifying anything that we have to begin with. The individual components can also be passed as parameters to the function, so you don't have to pass the entire array if you're just working with a single element of it. We also looked at strings in the previous module, and in C++, we looked at C strings. These are null terminated and stored as character arrays. There's a whole bunch of manipulation functions that we can do with them: string copy, string compare, string length. The problem is that those are deprecated. So, we want to be careful with using those functions a bit because they're in some ways dangerous constructs. Two-dimensional arrays, the elements can be arranged in table form, and you can have arrays that are even bigger than 1 or 2 dimensions. For a two-dimensional array, you need the pair of indices, one for row and one for column. And in row processing, the two-dimensional array is processed one row at a time. In the column processing, the two-dimensional array is processed one column at a time. So you can do them either by rows or by columns. Anyway, that's the presentation for today. Thanks so much for listening.